Solving absolute value equations and inequalities. First thing we're going to do is solve the inequalities. But an absolute value is used to represent ranges for dimensions of baseball bats, as you can see in the picture here. A compound statement is made up of more than one equation or inequality. A disjunction is an or, and it's graphed with the opposite directions. So think of going in opposite directions. A disjunction is true if at least one of the two parts is true. A conjunction uses the word and. Okay, uses the word and think of a dumbbell, the 2 points with the line connecting in between. Okay? Conjunction is true if and only if all of its parts are true. That means it must rest between the two numbers. And it can be written as a single inequality. The number less than or equal to or just less than, the variable, x is what we use a lot of times, less than or less than and equal to a number. So we're going to solve each of these compound inequalities. Then we have to graph the solution set. So make it say x first. Just make sure my pen's thick enough for you guys. So this would be x less than or equal to -1, subtract the 3, or x greater than 3, divide by 3. How do I graph that? Well, a less than equal to, still solid circle to the left, and then greater than, open circle to the right. Next one is an and, so we're looking for it to be a dumbbell. Remember, when you divide by a negative, the sign changes. So this would be x greater than -4 and x less than or equal to, add the 5, or add the 3, get 5. So it's closed circle at 5, open circle at -4, greater than -4, less than 5. Looking at the next one, x greater than 4 or x greater than or equal to 6. So what's this look like? Greater than 4, greater than or equal to 6. So what is a combination of the two of them but the greater than 4? Open circle. So I'm just going to highlight it that way. Pause the video and you try the check it outs. First one, solving, you get x less than 3 or x greater than or equal to 6. And you see that they do go in opposite directions. Remember, when you divide by a negative, you have to change the sign. Greater than -3, less than 4. Looking at the next ones, less than or equal to 2. I'm just going to add to my number line here. less than 17. So this is just the less than 17. Okay? So moving on. Moving on. Absolute value. Absolute value is written as such with those two straight lines. It is a distance from 0 on a number line. So that means it could be on either side of 0. Okay, think two solutions. Can be written, if you see in here, absolute value of 5 is 5, the absolute value of negative 5 is 5. So it's always going to be positive, it's a distance, okay? But the value inside could be both positive or negative. So there's some examples showing you that an absolute value of x equaling a single number is going to be 2 points. The absolute value less than, think and, less than symbol is and. And a greater is or. And you have to just remember what those graphs will look like. Okay, we set up two solutions, two equations, because again, what's inside the absolute value symbol can be either positive or negative. So, my two equations for an absolute value would be that x minus 7 equals the positive, or x minus 7 equals the negative. So this is x equals 12, or x equals 2 by adding 7 to both sides. Again, an equation equals is points on the number line. So in something like B, you have to isolate the absolute value first. Means make it by itself. So I need to subtract 5, and then I have what's inside equals both the positive or the negative. So x equals 3 or x equals negative 3. Again, an equals are points. So you try the next two, and then this video is done. Pause. Again, in 2b, you need to make sure that you isolate first, add a to both sides. Then, two equations. Solve for both, and answers 2 points. Day 1 video complete.